All right, section 3.3, derivatives of exponential and inverse trig functions. Okay, let's say I want to find out what the derivative of inverse cosine of x is. I don't know what it is, so I'm going to say, let's let y equal to the inverse cosine of x. All right, so that implies that x is equal to the cosine of y, using what we know about inverse functions, okay? Now, what if I go ahead and differentiate both sides of this with respect to x? The derivative with respect to x of x is equal to the derivative with respect to x of cosine of y. On this side I get 1. This side I'm going to have to use what? The chain rule, right? Derivative of cosine is negative sign, so that's derivative of the outside at the inside times the derivative of the inside. So that's 1 is equal to negative sine of y times dy over dx is another way I could write that in. Now let's solve for dy over dx. So let's go ahead and divide by this on both sides. So we get negative 1 over sine of y is equal to dy over dx. Okay? So in other words, I could say dy over dx is equal to negative 1 over sine of y, right? Or I could say dy over dx is equal to negative 1 over the sine. But instead of y right here, what did we say y was? Y was the inverse cosine of x. So I can sub that in for y right there. The inverse cosine of x. Well, that looks like a mess. Negative 1 over the sine of the inverse cosine of x. Let me see if I can rewrite this somehow. Well, yeah. Back in chapter 1, we learned about right triangles, and we learned about using the triangle properties, right? All right, what does this mean, the inverse cosine of x? That means the angle whose cosine is x. I'm going to say it's this angle in my right triangle. So what does that mean, the angle whose cosine is x? So if I take the cosine of this angle, I should get x. The easiest way to do that is call that x, call that 1, right? Well, if we use the Pythagorean theorem right here, to find the length of this side, it'll be the hypotenuse squared minus this side squared under the radical. All right, so let's see if I can figure out a neater way to write this. dy over dx is equal to negative 1 over, what is the sine of this angle? Here's that angle. What is the sine of it? Opposite over hypotenuse. So I could call that 1 over the square root of 1 minus x squared. So what are we saying here? We're saying the derivative with respect to x of the inverse cosine of x is negative 1 over square root of 1 minus x squared. Don't worry, you're not going to have to derive this for this class. You'll need to know that stuff for Calc 2 whenever you get to integration with trigonometric substitution, but, you know, you'll learn it there. All right, so let's look at this. Let's look at some derivative formulas. Suppose we have the derivative with respect to x of the inverse sine of u. Now we're looking at u, like we're not just looking at x being there. U could be some function of x. That's going to be 1 over the square root of 1 minus u squared times du over dx. All right. We also have the derivative with respect to x of inverse cosine of x. Inverse cosine of x. You call that u. That's equal to negative 1 over square root of 1 minus u squared times du over dx. Know these. Memorize these, okay, so you don't have to go through that every time. Because we're looking at them one way here. At the end of the semester, we're going to go backwards and do antiderivatives with this stuff. And we also have the derivative with respect to x of, what do we have next? Inverse tangent of u. I keep wanting to write x there. All right, so that's going to be 1 over 1 plus u squared times du over dx. Memorize those three. Otherwise, you got to derive it. All right, so let's see. Let's work some examples now. Suppose we have an example that says find y prime. And part A, we're going to have y is equal to square root of x times the inverse sine of x, like this. So I want to find the derivative of a product here, right? So I'm going to use a product rule. Y prime is first times the derivative of the second plus the second times the derivative of the first times the derivative of square root of x. So square root of x comes down. Derivative of the inverse sine, what does this say? It's 1 over the square root of 1 minus the argument squared times the derivative of the argument. So let's see, I'm going to have 1 over the square root of 1 minus the argument squared. What is the argument here? X. So I'm going to say x squared times the derivative of that argument. Well, what's the derivative of x? It's just 1. Plus the inverse sine of x times, let's try to do this in our head without converting it to 1/2. That'll be 1/2 x to the negative 1/2. All right, so this is square root of x times 1 is square root of x up top over the square root of 1 minus x squared. Times 1 is just itself, right? Plus, I could call this the inverse sine of x over 2 square roots of x if I wanted to. All right, let's take a look at B. B. Then I have to erase this. I need more room. B. Part B, we're going to have y is equal to the inverse tangent of x squared. All right, let me maybe write over here that formula again, okay, because you haven't seen it much yet. The derivative of the inverse tangent of u is 1 over 1 plus u squared times du over dx, we said, right? Okay, give you a second to write that. All right, so if I want to take the derivative of this, I can say y prime is equal to 1 over 1 plus the argument squared. What's x squared squared? X to the 4th times the derivative of the argument. So that's 1 over 1 plus x to the 4th times 2x. Or we can say 2x over 1 plus x to the 4th. There we go. All right, let's look at some derivatives of exponential functions. Derivatives of exponential functions. Actually, let's make a new video.